Hi everybody. Today I'm going to discuss the geometric interpretation of eigenvector, or why eigenvector are so important. Eigenvector of a linear transformation are so important because they help you to understand what the linear transformation is really doing in a very simple way. First of all, about linear transformation or matrix. A linear transformation transforms a vector to another new vector. So if you multiply a vector v by a matrix T, you get a new vector b, and you could say that the matrix performed a linear transformation on the input vector v and produced a new vector b. Here how it is written mathematically: the matrix T acting on vector v produce a new vector b. So tv is equal to b. And here is an example. We have a vector v whose x and y coordinate is 10. So you could write the vector as a row vector 10 10. And we have 3 0 0 and 0.5 2 by 2 matrix or linear transformation named as T. Now when the linear transformation T acts upon the vector v, it produces a totally new vector tv or b, whose length and direction is changed from the input vector v. So the direction of input vector v and the output vector tv or b is different here. Here again, it is shown that how a linear transformation transforms a vector to a new vector whose direction is different from the input vector. Now notice when the linear transformation T transforms the vector v into a new vector tv or b, it's possible to find some vector. Here is in this case the two little rate basis vector, which are just scaled by the linear transformation, i.e. the linear transformation just scale the vector, but the direction remain the same as previous. Those vectors are called as the eigenvector of a linear transformation T. And the amount of length, which is a scalar number only, by which the vectors are scaled, are called eigenvalues. So the definition of an eigenvector, therefore, is a vector that responds to a matrix as though the matrix were a scalar coefficient. In this equation, T is the matrix and X is the vector, and the lambda the scalar coefficient by which the eigenvector gets scaled. And it is obtained by solving the following matrix equation. You can check any textbook of linear algebra about how to find eigenvectors and eigenvalues of a linear transformation. So here it is, Tx is equal to lambda x. So why is the eigenvector is important? Because often it is hard to visualize what a linear transformation is really doing to the input vector and how it is doing so. But when you express the input vector as a linear combination of eigenvectors of a particular matrix or linear transformation, then it gets really easy to understand what the matrix is doing with the input vector and the transform into a new output vector. So here is an example. So consider a 2 by 2 matrix T, and V is the input vector, and TV is equal to B is a new output vector as usual. But from this equation, you really don't understand exactly how V get transformed into new vector B. But suppose V1 and V2 are the two eigenvector of the matrix T, and lambda 1 and lambda 2 are the corresponding eigenvalues of the matrix T of corresponding eigenvector. By definition, if you act the matrix T upon the V1 eigenvector, it only gets scaled by lambda 1. So T of v1 is equal to lambda 1 of v1, and t, and as usual, and it is the same for the eigenvector v. So t of v2 is equal to lambda 2 v2. So now taking the eigenvector as a basis, and let's express the input vector v in terms of the eigenvector v1 and v2 of the linear transformation t. So v is equal to c1 v1 plus c2 v2, where c1 and c2 are the coefficient. Now we can write the transformation t acting upon v is t of c1 v1 plus c2 v2, and now c1 of t of v1 plus c2 of t of v2, and c1 and t and the v1 just gets scaled by lambda 1, so c1 lambda 1 v1, and v2 is just scaled by lambda 2, so plus c2 lambda 2 of v2. Consider the real example. So we have a matrix 30, minus 4 and minus 4, 7, and a vector a1 and a2, and the result, the new output vector is 13 a1 minus 4 a2 and minus 4 a1 plus 7 a2. Now how it is doing, how the linear transformation t is transforming the vector a and a2 into a new vector. To understand this, now by solving tx is equal to lambda x, we find the eigenvalues 5 1 and lambda 1 is equal to 5 1 and lambda 2 is equal to 15, and the corresponding eigenvectors are v1 is equal to 1 2 and v2 is equal to minus 2 1. So we can now decompose the original vector a1 a2 by the above eigenvectors. So c1 is equal to, so a is equal to c1 v1 plus c2 v2, and c1 and v1 is unknown coefficient. Now when you act the matrix T on A, you are really acting the matrix T on the linear combination of c1 v1 plus c2 v2. So what it really does is it scale the vector 1 2 v1 vector by 5c1 plus is scale the vector minus v2 is or minus 2 1 by 15c2. And here is the example. So suppose we have the blue vector as a vector A, and after the linear transformation we have got the yellow vector. Now how the linear transformation is transforming the blue vector into yellow vector, to understand this, we first have to find the eigenvector of the linear transformation. And after finding the eigenvector of a linear transformation, which is shown here, the two red vector, now we can decompose the blue vector in terms of the two red vectors, two eigenvectors, and then we can see that this red vector is just gets stretched by some amount in both direction by the following linear transformation, and eventually it produced the yellow vector. So this is the reason eigenvectors are really important, because it's really make us to visualize the linear transformation in very simple way.